Hello, everybody, and welcome to the second session of Glow Your Own. I'm Dane. I'm joined here with three brilliant women. There's Sophie, Sarah, and Caitlin. So you remember Sophie and Sarah from last time. Sophie leads on the coding, and Sarah is a troubleshooting expert. And also we're joined today by Caitlin Powell, who works at the UK Atomic Energy Authority. So Caitlin's going to be joining, making some things, and possibly making mistakes, like I will be making mistakes. And we might get to speak to Caitlin a bit later. But Caitlin, if you'd just like to say hello and maybe say what you do as a job.
Hi, yeah, I'm Kate. I'm a software engineer, UKAEA, so that's the UK's National Fusion Lab. Fusion's the process that powers the sun, so we do research into how we might be able to make fusion happen on Earth. But it's really hot, so it's really hard. My job in particular is to work with and handle the data that we get from JET. So that's the Joint European Torus, and that's one of the fusion machines that we have on site. So I try and handle that data so that scientists can find it and they can use it in their research.
Well, I'm really happy that you're able to join in with this project again and bring some of your hot knowledge to this project. So I'm going to hand over to Sophie.
Fantastic, thank you, Dane. And I like your terrible jokes, so I think you can carry on with them as far as I'm concerned. I don't think it would be the same without them. So hi, everybody. Thank you for coming back this week. It's lovely to see you all. We're going to do some exciting things with real Arduinos this week. We'll build our real circuits and we'll really make our lights flash if we do it right, that is. So I've got my Arduino ready here. So this is what we'll be using. If you don't have your Arduino yet, don't worry at all, because we've got the, you can do everything virtually. You can do it all online on the computer, and Dane is recording this, so you can always look back when you do get an Arduino, or if you do get an Arduino, and make it in real life for yourself. Okay. I don't think I said last week, but this is where I work. This big place behind me, this is the Rutherford Appleton laboratory. We're a big science lab doing all kinds of things, from the tiniest things in the universe to the biggest things in the world, looking at health science and security and green energy, all kinds of fun stuff. And one thing that joins all of them together is the fact that they all rely on the kind of things that we are going to be doing today. So they all rely on coding things like this. All right, so I'm going to share my screen and we will get started again. So can you all see that? Dane, what's the first thing we should do when we start a new circuit?
Well, we probably want to start with a microcontroller, don't we? So an Arduino.
That is a good start, but first I'm going to name it.
So of course.
I know what I'm doing. People online know, they've been telling me. So we're going to name it. So let's call it, and that's so that we know what we were doing and we can find it nice and easily. So I'm going to call it GYO, Glow Your Own 2. Maybe I'll call it 2 Real Arduino, just so I'm doubly sure. And that means that I'll be able to find it nice and easily. But then, Dane, you are right. I'm going to start with my Arduino, my microcontroller, my small thing that controls other things, and then I'm going to get my breadboard out ready. Now, what we're going to do is we're going to just quickly recreate the circuit that we were doing last time, a simple circuit that turns a light on. But as we do it, we're going to get the same components out in real life. So I've got my Arduino out on the board, and this is what the Arduino looks like. Now I'm going to switch on my Arduino camera. And let's see, I'm going to see if I can spotlight my Arduino camera as well, so everyone can see it, so that you can see this a bit more clearly. So you can see the LED here. If you've got your LEDs, you will notice something about the legs. It's having a bit of trouble focusing on it because it's so small. You can see something about the legs here. Anyone tell me what they notice about the legs?
One smaller.
Brilliant, absolutely right. One of them is shorter than the other. And you remember last time we mentioned that that they only work, LEDs only work if you put them in the right way around. The reason that one leg is shorter is so that you know which the right way round is. So we're going to put our LED so that the short leg is to the left hand side, okay? So you just pop it into the breadboard so it stands up nicely like that, okay? Okay, all right, I'm going to share my screen again now so that we can build the next bit online. There we go, and I'll pop this down. So let's build the rest of our circuit virtually, and then we'll do it. Online, okay? So now you'll remember that we needed to connect our Arduino to our LED. So I'm going to go from pin 4 with a wire. So I click on pin 4 in my Arduino, over to my LED like that. And then I'm going to move my Arduino so that my wire is nice and straight, because I like that. Like that. And then we're going to do another wire from the ground, the one that says GND, up to the blue line. And then I'm going to change that wire to be a different color, orange, so it's easier for us to talk about. Okay, now that's not quite finished, is it? Because we're not going the whole way through. So at the moment, our circuit goes from our Arduino up through our wire, through our LED, and then it hasn't got anywhere to go. It's not connected to anything. So I need to connect my LED to this line here, and we do that with a resistor. So we pick the resistor up, we pop it here, and then remember we wanted one that was 200 ohms, 220 ohms, like that. And then that's our complete circuit, and that's what we're going to build in real life. Okay, so I'll leave that up, and then just give me a thumbs up when you have built that on the computer, because then you can look at that while we're looking at the Arduino cam. Give me a thumbs up or an emoji or anything like that. We've got a thumbs up. Fantastic. Just so you can all look at it. We've got some more thumbs up. Brilliant. Fantastic. Really well done, everyone.
I got it.
You're all doing really well this year. I'm very impressed. Also, the emojis get really, I think they're getting cleverer. They move around and everything.
Was it 200 ohms or 220 ohms?
So you can pick whichever one you like for the online one. Either will work for this.
So just so you know, so everyone's been sent out. So I'm just holding mine up to the camera. So mine looks a bit like, well, mine looks exactly like that. And yours should look the same if you've been sent one out from the festival in the past few days. So it's a bit like different sorts of cars. So you might have a Ford car or a BMW or a Vauxhall. So the Uno Arduino and the Freenove, they're just different sorts of the same thing. So don't worry about if it's got slightly different writing on it, but all the pins and all the rest of it should do the same thing.
Okay. All right. I think that most people have done it on Tinkercad. So I'm going to stop my share so that we can focus really in on the Arduino, which you should be able to see in the Arduino cam. Can everybody see Arduino cam? Yeah?
Can you see it? Yeah.
Can you give me a thumbs up? Yeah, we've got some people saying yes, thumbs up or an emoji or something in the chat just to show that we're there. Okay, so now we need to make our wire, we need to connect our Arduino to our LED. Okay, so we're going to use a wire. I should have got my wires out, shouldn't I? Here we go. Now, you'll see that these wires, they're all quite, all of these bits are all quite small. So it's really important, everyone, that you make sure that this is kept out of reach of any babies or any animals. So when we're finished, I want you to make sure that you look around on the floor and on the table to make sure that everything has been picked up, that you haven't accidentally dropped anything, and that no small people that might like to swallow them, to swallow any of these components are nearby, okay? Just have to be really careful when we're working with them. All right, now I've picked up a green wire. Here we go. You can see, so some of your wires will have these little metal points on the end. Sometimes we call them jumper wires. They might look slightly different, but they all look like this. So I'm going to get my green wire, and just like on the computer, I'm going to connect it from pin 4 to my LED. Okay, so let's start with the LED. Focus in here, and I'll put it down there. Oh, sorry, my fingers got in the way. My fingers are going to have to get in the way because otherwise it won't go in. There you go. So you can see that it is in that same column as my LED. And then I'm going to take it to pin 4 on the Arduino. I'm just going to give my camera a second to focus. There you go. So 1, 2, 3, 4. There we go. And then I'm going to count again and realize that I'm not very good at counting. And I'm going to put it in the actual pin 4. There you go, pin 4. Now I saw that somebody popped in the chat, does it have to be pin 4? You can use a different pin, but we just need to make sure that our code is sending the instruction to the right pin. We'll do the code in just a minute once we finish building the circuit, okay? So we're getting closer with our circuit. I'm going to do the wire next. So I'm going to pick an orange wire here. Oh, here we go. And you'll remember that that went from the ground to the one of these lines, to the blue line here. So this went from the ground, and you'll see that ground is down here. That's not focusing properly. There we go. Ground is here. So let's put it in the ground. Oh, and I've just looked that there is a pin that's broken off on my ground, which is not going to make life easy for me. So you can see this is not supposed to happen, everyone. There's a little gold bit in there, and that means that one of the bits of wire has actually got snapped off in there. I'll go and try and fix that later, but there are other ground pins on this side as well. Focus, there you go, that say GND, so I'll use one of those instead. Sorry about that. And pull it over to the blue line, just like we have in the virtual circuit. All right. Okay, so how are we doing, everybody? We should have an Arduino, a breadboard, an LED, a light, and 2 wires. So the ground, the wire that connects the ground, has to go to this blue line here.
So there's a secret behind these blobs. So maybe, Sophie, you could just describe what the breadboard looks like underneath. Sometimes you can see underneath, but you can't. Yeah.
Yes, underneath these little dots, they're connected in these strips.
I'm just taking apart a breadboard.
Oh, awesome.
Very sort of. So I don't think you should do this yourselves.
No, don't try this at home.
Definitely don't try this at home, but I'm not going to ever use this one. This is an old breadboard that I'm not going to use again. So if we could just, I'm going to jump in and spotlight myself for a second. Yeah. Replace spotlight. I don't really know what that all means, but there we go. So this is the breadboard you've got. And so the thing that's really useful about these breadboards is that you can just plug these jumper wires into the holes without having to do any soldering. So that's why we use breadboards. It makes the connections a bit like putting Lego together. So it makes things so you can just plug them in and it goes into pin 1 or pin 2 or pin 3 rather than it goes somewhere along a circuit wire. And so I've just taken some of the sticky off the back of this breadboard. And so behind it, there are these bars of metal that will connect. This is the front of a breadboard, and that's the back of a breadboard. And so you can see, so when we connect to, for instance, this wire here, so on that pin, if you can see it, behind where this wire goes is a bar, which means all of the dots, all of the little holes on this line here are all connected, but they're not connected to that line adjacent to it, if that makes sense. So as I'm holding it, all of these pins along that vertical stripe are the same pin, so if you can follow me with that. So they're all connected. And this vertical stripe just next to that stripe where the jumper wire is plugged into, they're also all connected. And then where we're putting the LEDs, and we're putting our LEDs, just going to put one in just to show you. So we're putting our LEDs in these pins in this other section of the board. And so you can see where I've ripped away the sticky part of the back of the breadboard here. There are other metal bars that connect all these. So what you can't see is these ones are connected like that. And these ones on this kind of stripy bit, these two lines at the side are connected like that. So that's why we have to line things up like this, where we put our LEDs and our other components like resistors, and later on we'll be putting in our light sensors. So that's the reason why it doesn't really matter which hole you put it into on the breadboard, because behind it they're all connected with these vertical and horizontal bars. Hopefully that makes sense a bit. So I'll pass back on to Sophie now.
No. That's really cool. And I don't think I've ever seen the breadboard like that. So I've had a lovely time.
So don't rip your own breadboard up because it will damage it and it won't work.
Please don't. I think you can see that now. All right, so now we are going to do the last part of our circuit, the resistor, which some of you have asked before. Now, this is what resistors look like. They often come in these nice little strips, like this, with lots of them, because you need lots of resistors normally for circuits. And some kits very kindly write some numbers on that piece of paper. So if you look carefully, you can see that that says 10K, and that tells you the strength of the resistor. That's 10 kilo ohms. Now we want a resistor that's a few hundred ohms. So this one you can see is 330. So I'm going to use this one. Your one might be 220. That's a really common one. But different resistor, different Arduino kits give you different numbers. As long as it's a couple of hundred, it will be fine. So what you need to do is pull out one of these. So I've got one that I did earlier, but I've twisted it up in a way that I probably am not going to be able to untwist on camera. Oh, no, yes, I can. There we go. And it looks like this. If you look closely, you can see that there are some colored bands at the top, and they will also tell you what value the resistor is, because it's a code and it tells you what value that resistor is. All right. And now we want to complete our circuit. If I move over here, that means we want to go from here. So it's connected to that orange wire to here. So it's connected to our LED. Actually, if I turn around that way, you can see a bit better. All right. So let's pop it in this wire like this. There we go. And then down to the thing. Sorry, I'm not very good at doing this with one hand whilst also keeping the camera onto the Arduino. There we go. So yeah, can you see that that is connected to the LED and to the wire, just like our real circuit? Okay, so you want to use a resistor that is 220 or 330 ohms, like that. Okay, and so that is what your circuit should look like. Turn Arduino cam off for a minute while we do that coding, right? So your circuit is like the circuit that's drawn here. And now we're just going to code it. Oh, I'm going to move this over so that you can see it all. We're going to code it. Now, you'll remember that we had some code that we didn't want in here, so we're just going to delete all of that. Delete that. Delete that. I do really like the noise that it makes when it deletes. It's really cool. And then we're just going to do the same circuit that we did before. Okay, so we're going to have an instruction that says, Arduino, turn the light on, and turn it on forever. So we're going to use a forever loop, which you can find in control. LED is connected to pin 4. Now, like we talked about before, your LED might not be connected to pin 4. You just have to make sure that this number here tells the Arduino where to send the instruction. Okay, and make sure that your LED is connected to the same pin on the computer as it is in real life. Okay, now let's just double check that our circuit, our code is working. So we're going to do start simulation and see if our light online turns on, which it does. Hurrah! That all worked. Okay, so the next step is to take the code and put it onto our real live Arduino, which is always the fun bit. Your resistor, if I zoom in a little bit on my code, your resistor goes from this leg from your LED to this blue line here. Okay, so this is your resistor, and it goes from the line of your LED to the blue line. So if we want to trace our circuits, you go from the Arduino to pin 4, up along the wire to the breadboard, through those strips of metal Dane showed us earlier, through the light or the LED, back down the breadboard, through the resistor, and then along the breadboard, along the blue line. And here is the code again. Sorry, I hid it for a second, didn't I? So the code is here. So we just want a forever loop, which says Arduino, do this forever. And what it wants to do is turn pin 4 on. Okay, brilliant. If you do have any questions, then you can always pop them in the chat. and Sarah and Kate are there to help you. And we will also, remember, have our troubleshooting session at 6 o'clock once we've finished the main session. Okay. The resistor, remember, goes between the LED and the blue line on your Arduino. Okay, that's where your resistor goes. It's this wibbly thing here. All right. And it should be in the same place in real life. So I'm just going to show you where the resistor is in real life. So here is my circuit. There's my Arduino. Got my LED here, and then my resistor, sorry, it's taking a second to focus itself, is this thing here, this blue thing, okay? That goes from the LED to the blue line, okay? Sorry, hang on 1 second. Right. To do is we're going to connect our Arduino to our computer and send it the code in real life, which is always really fun. Before we do that, though, some really important thing. We have built this lovely little circuit, which is going to work brilliantly. But when you are working on circuits, whether it's a small little circuit like this or a giant big circuits like the ones that we use in our big experiments behind me, or the ones that Kate uses at the UKAEA, a really good thing to do is always to make sure that if you're changing anything with your circuit, so if I said, you know what, I don't want a red LED, I want a white LED or a blue LED, you never change any of the components while it's connected to power. So for us, our power comes from the computer, so we don't want to change any components while it is connected to the computer. So any changes, just unplug it from the computer before you want to do that, okay? Right. Now I'm going to pop Arduino cam down a second so I can show you how to make the, how to get the code to it. Right. So on Tinkercad, you'll see the code is over here. And then you can see this thing that says blocks, right? Now, if you click on that, you can change it to blocks plus text. So if you do that, then this whole other thing comes up, some words. And this is just a translation of your code. So it's the same code, it has the same instructions, but it's just different, written in a different language. It's kind of like saying, bonjour or hello. So it's saying the same thing, just in a different language. But this language with the text is easier for the Arduinos to understand. So we want to have this thing, and then you can highlight it with your mouse, like you'd highlight anything in like a Word document or anything. Highlight all of it and copy. So you can do that either by pressing Control-C, which I've just done, but you couldn't see, or by right clicking and doing copy like that. And remember, you get this up by going over here to the thing that says blocks and changing it to blocks plus text. Like that. All right, now comes the fun bit. What you want to do is open up a new tab in your browser and go to something called the Duino.app. Like that. So everybody click on the Duino.app. So you should see a bit like this. And what we want to do is we want to code. So you come over to this top left corner and you click code. Right? Okay. And then we're going to create a new project. So you can call it whatever you like. So I'm going to call it the same thing that I called it in Tinkercad, Duino-2 real Arduino. Create. And you get it like this. It gives you some code that you could try if you wanted to, but that's not the code we want. So I'm going to delete all of that. You just highlight it and delete it. And then I'm going to paste what I copied before. So you just do Control V, except I've just copied the Duino app, which is really silly of me. Sorry, everyone. So I've got to head back to Tinkercad. If I were on blocks, I would go to this bit here, just to the left of the code, change blocks to blocks plus text. So this should work in other app browsers as well. You should be able to use that. If your browser isn't supported, we've got a different method for you. Sarah, can you grab out the Arduino one? Thank you, that Sarah will put in. So I'm copying this. Try it in Duino anyway. So you do Control C to copy, and then in the Duino app, you do Control V to paste, like that. Okay. So you do Control V once it's copied. If you want to do it again, let's see, you can Control C, or you copy in here. And then in this, the Duino app, you do Control V. All right. So everyone do a tick or a thumbs up or something once you are there. We've got a fair few steps there, so we'll see how we're doing. You shouldn't have to create any users, any accounts or anything for the Duino app. It should just be open.
This is for the Arduino,
For the Arduino.
online. So sorry about that, but hopefully you'll get in eventually and we can help you when you're ready.
Yeah.
We've also got saying that you can't paste anything. There is a couple of different ways you can copy and paste. You can use your mouse to right click on the area that you want to copy, and you'll get a little option pop up and you can click copy and then right click and paste on your other screen, or you can use keyboard shortcuts of Control C for copy and Control V for paste. I'm not sure which one Sophie used, but there's a couple of different things. So if it only shows cut or copy, it means maybe it didn't copy itself properly the first time. So go back into Tinkercad and highlight your code, your text bit of the code, and see if you can copy that again. I'll pass back over to Sophie, sorry.
That was great. Thank you, Sarah. So yeah, we can help during the troubleshooting session if anyone's having difficulties with that, because then we can share screen, you can share your screens and we can have a look at it more easily like that. Just typing it in works as well. Okay, so once you're in the Duino app and you've got your code, we are going to connect our Arduino to the computer. So Arduino cam is back. Here we go. You should also have a USB wire, which you can see I've already connected to my computer up there. And then I'm going to plug it into my Arduino. And I realized that I should have thought about this because my Arduino is now too far away from my computer. So I just need to pull it a bit closer. So you can see it goes into this hole at the side of the Arduino. And I'm going to have to put Arduino cam down for a second because I need two hands to plug it in.
Oh, not Arduino cam.
And there we go. So you can see that now the wire is connected to my computer up there. And you can tell that it's connected successfully because you can see on my Arduino, there are some little lights. Okay. And those lights mean, yep, I'm getting power, everything's okay. All right. Now, the next thing we need to do is to send this code to our Arduino to send these instructions. The first thing is down here at the bottom, you have to click select device. So this is us telling the computer where our Arduino is. Now, the things that show up on this Arduino depends on your computer. They call different things, which is not very helpful, but it's normally the one that it says USB serial device. Sometimes it says Arduino. If it does say Arduino, pick that one. But basically, if it doesn't work, we'll try again. Okay, yes.
What button did you press to get that?
The button down here that says select device. And then the moment of truth, you need to send your your instructions to the Arduino. All right, this is normally where I find out I plugged my LED in the wrong way around. So you'll see up here in the top right-hand corner, there are some buttons. We'll talk about all of them at some point later on. But one of them, the middle one, that looks like a play button, if you hover over it, it says compile and upload, which is computer speak for turn it into language the Arduino can understand and then send it to the Arduino. Okay, and that's the button that you need to click. So you click that button and then it says compiling code. That basically means it's thinking about it. Then it says uploading code and look, and then 100% done. And then on Arduino Cam, you can see that my light is now on. So if you do that, your light should turn on, which is amazing and always exciting. We'll have a look at each people's in the troubleshooting, because it depends which bit you're doing. So
yeah, just stay behind, and we'll help you afterwards, because we're close to 6 o'clock.
We are indeed. The button that sends your code to your Arduino is this one here, compile and upload, which looks like a play button. So once you've done that, then you've got your working circuit, which is awesome. So just to repeat, once you've got your code in here, your device selected down here, if it didn't work, then sometimes it's just because you picked the wrong one, because they call it weird things. The computer calls them weird things. So just try a different one. So mine's the USB serial device. You click connect, and then you send it by doing compile and upload. Oh, we've got some people with lights on. That's fantastic. Well done, everybody. Okay, that is a whole bunch of new stuff. You've all done really well to keep up, and I've got some brilliant thumbs up. Well done, everybody. You've done so well to catch up, to keep up. Remember, if you don't quite there, we'll do the troubleshooting in just a few minutes. We've also recorded all of this, which means that you can watch it back, you can record it, or you can pause us in the different places so you catch every word. Okay? All right, I'm going to hand it over to Dane. We've got some brilliant ones. Mine is on. Fantastic. I'm going to hand back over to Dane, and then we will see you all very soon. Okay? Oh, I've got to stop my share as well.
Well, I'm really happy that some of you have done some really great coding and making. I know some of you have had a little bit of difficulty, but that's no problem, because there's always the on-demand catch-up version, and there's the worksheet that we can always use to kind of have another go. So the most important thing is to persevere and don't get stressed out and don't get upset when things aren't working. It's usually something quite straightforward and simple. So what we want you to do is to enjoy what you're doing. Hopefully everyone is able to kind of have another go once this is finished. But if you are struggling, please stay behind. We're going to do the rest of the session with cameras on in a second. But well done to everyone. If you need to go, go. If you want to stay, if you've had difficulty or not had difficulty, stay behind. Got another half an hour of troubleshooting to do, and everyone is going to get their light flashing, hopefully, in the next half an hour. But thanks so much for coming to session 2 of Glow Your Own. We'll see you next week, but please do some tinkering in between. We'll see you next time. Bye.
Bye, everyone.